is the multiplicity of A?
Complex.
No, it's not in this case. Look closely. You guys have this printed out. Do you see? Again, I know do you see there's 1 and 1? It's a doublet.
There's a like a middle one.
That's the CDCl3 at 7.24. Solvent, ignore. Solvent we ignore, TMS we ignore, because those were added by us. We good? So if you look at signal A, do you see it's a doublet?
Yeah.
What about signal B?
Also doublet.
And what about signal C?
It's confusing.
Signet. Doublet for 2 hydrogens, and I want to remind everybody, this is doublet for 2 hydrogens, doublet for 2 hydrogens as well. And of course, this is a singlet for 3 hydrogens. But let's focus on this because it never gets clearer than this. These signals are benzene signals, right? What is 2 hydrogens plus 2 hydrogens?
4 hydrogens.
So, what substitution pattern does the benzene ring have? If it has 4 hydrogens, how many other things must it also have?
2.
So this is a di-substituted benzene. Everybody okay? But here's the trick, the neatest part. When you have di-substituted benzene, how many kinds of di-substituted benzene are possible? How many arrangements of di-substituted benzene are possible?
3.
3. What are those 3? 1, 2, 1, 3, and
1, 2, 1,
4.
3, and 1, 4.
Which of them? 1, 2, 1, 3, 1, 4 will give us 2 clean doublets. Louder? Only this guy is capable of producing a multiplicity pattern which is as clean as that, a doublet for one set of hydrogens, 2 hydrogens, and another doublet for the other set of 2 hydrogens, which very clearly tells me that this benzene is a 1,4 di-substituted benzene. It's a very important piece of information.
Wow.
Whenever you see 2 doublets integrating equally 2H2H, it's a 1,4 di-substituted benzene, period. Nothing else is possible. Oh, 1, 2 will, again, if X and Y are different, which we are assuming they are different in this case, you'll get complex. Exactly. But this is the cleanest one. This is the one that's easiest to become. Are we all good?
Yes.
Okay. What about this? We said it is a CH3, that's a singlet. Yeah, you're right. Singlet, which is CH3, which means it is not connected to any other hydrogens. So we have a CH3. Agreed? Can we just pause here for a moment? How many carbons have we accounted for by these 2 pieces alone?
All 7.
7.
Wouldn't it be 6?
Why? Well, no, 1, 2, 3, 4, 5, 6, 7.
Oh, my bad.
How many hydrogens have we accounted for in these 2 pieces only? 7. 1, 2, 3, 4, 5, 6, 7. What's left?
The oxygen and bromine.
Oh, how does that fit? There's something wrong with the formula. Oh no, there isn't anything. No. I didn't say that. Sorry, I didn't say that. Sorry.
I'll erase it.
So what's left? How many bonds does oxygen want to make?
2 bonds.
So we have, sorry, let me not do it. Sorry. So we have this piece. We need an oxygen that wants to make 2 bonds. What else is left?
Bromine.
How many bonds does bromine want to make?
1.
So we have this piece. All we have to do is somehow take these 4 pieces, put them together, that aligns the structure. Suggestions? Yes?
You can bond the CH3 to the oxygen, then bond the oxygen to the benzene ring, and then bond the bromine to the other side of the benzene ring.
So you are saying bond an oxygen here, bromine there, right? And then oxygen has,
Yeah.
that what you're
Oh,
saying?
wait, no.
Yeah.
Yeah,
Oh.
wait. That was what I was thinking as well.
Oh, that's not what I was saying.
Yeah.
What were you thinking? I'm
I
curious.
thought the oxygen to the bromine.
But then where does this go? Where does this go?
On the other side.
Oh, I see. Why would oxygen want to bond
I
with
don't know.
Who knows? But
No.
I
Okay,
was thinking the exact
that's
same.
perfect. Now guys, also, okay, let's look at that possibility. But let's finish this first.
Okay.
Do you agree that this is signal C?
Yes.
Now, which of these will be signal B or sorry, A or B? Is this A or is this A?
He's gonna be, wait.
So which signal do you expect to be more shielded or de-shielded? That's the whole idea. Where is A?
Closer to the bromine.
Closer to the bromine. Why closer to the bromine? Why not closer to the oxygen?
Bromine is a more electronegative.
No, it's not.
Oh.
No, it's not.
Inductive effect?
No, it's not. Well, if you were going inductive, oxygen is way more electronegative than chlorine or bromine or iodine. Fluorine, of course, is an exception. No, it's not inductive effect, it's resonance effect. Oxygen has lone pairs of electrons, if I might draw it here. Oxygen has lone pairs of electrons that get pushed into the ring. Those get pushed into the ring. When they get pushed into the ring, what do they do to those carbons?
Rich.
Right? If you were to draw out the resonance structure, wouldn't this become minus? And same with that as well. So these are actually shielded. They have higher electron density because of the oxygen's lone pair being pushed in there due to resonance effect. And that is why signal, this is B and that's A. Now someone said earlier that, okay, let's do that. This was another option that was suggested, OPR and CH3. Okay, let's see if there is any clues in the spectrum that might help us decide yes or no. My suggestion is, can you tell me where is the expected chemical shift for the singlet? Where would we expect that signal to show up? If it's attached to a benzene ring? About 2. We are not.
That's true.
It should have been here somewhere.
It's
not.
It would also be a doublet, I guess.
No, it won't be a doublet because there's no hydrogen. Oh, because of those?
Yeah.
Again, that's only within the benzene system.
Oh,
Off the benzene system, the coupling is very small. Does it exist? Yes, it exists, but it's very small. And that carbon doesn't have any hydrogen, so you can completely ignore it. But the chemical shift is drastically different from what you would expect. Are you guys all seeing it?
Yeah.
So I don't think it's that. It can't be that. That's what I'm leaning towards.
Not only that, I don't think resonance would make sense because the BR responded to the
Well, the oxygen still has lone pairs.
Yeah.
So resonance can still happen.
Oh yeah. But the CH3
Okay,
on the
let's try out the next one. Are you guys having fun yet? Expanding your brain?
No.
Yes, sorry.
Back to the other one, when I said B would be, like which one would be which, if A would be closer to bromine or if B would be closer to oxygen. Could you also say that just because of the positions, like B is closer to the peak of the CH3? So
What does that have to do?
I don't know. That's
You're
that's
right, B
kinda
is
why-
closer to C, but it's still pretty far away for C to have any effect on B. Is that what you're saying?
But that's just kind of how, like, when you asked, that's why I said that.
Okay, what if that were hydrogen instead of CH3? What if it were just a hydrogen? Would that argument change? But it shouldn't, because the argument about resonance is still the same. Oxygen having lone pair, it can push electron density via resonance into the ring. So, what's that? Okay guys, let's try the next one please. IHD is equal to what?
3.
I I heard 3 not possible. Not based on this structure, spectrum. Guys, do you know why I'm saying it? Without even doing the math, is there a clue that told us 3 is not even possible? Who it comes here? Who comes here?
Benzene.
So automatically 4. So 3 is not possible, right? It has to be 4 or more. So what's the IHT, please?
14, 16.
So half of
16.
C7H16 minus C7H10, am I right?
Which is 6.
Which is 6, which is 3. What have I done wrong here?
This is the wrong compound. Do we
Let
get to figure
me,
this out?
ooh, I think my formula is wrong.
Wait,
Can I
why-
do-
why did-
no, it's this
Why did you do
formula.
H16?
Oh, yes, my formula is wrong. Could I do some mental math? Give me a second. Just 1 second. Oh, it has to be, guys, my formula is wrong.
It's meant to be the
CAH9.
It has to be C8. Let me confirm. Okay, give me a second. One more. Yes.
Isn't it C?
It's C and
C16,
Yes,
isn't it?
yeah.
H9.
But it's C, not the
So what is
H.
the IHT then?
no, because we're doing the C and
C8.
H.
HAT
Yeah, like the
minus
format.
CAH.
Oh,
C8.
okay.
Is that 4? Okay.
I thought it was.
Phew.
Whatever.
That's a sigh of relief. Because 3 wouldn't have made sense. I mean, something's not aligning right. Are we good?
Yes.
Okay. Once again, whenever IHT is 4 or above, think about benzene. So is benzene possible here?
Yeah.
Which is the reason why we were having that initial doubt about the formula. Absolutely. How many signals? 4. Everybody agrees? 4? Is everybody okay
Why are
with
we
that?
doing the H
Cool.
instead of the C?
I'm just going
Because
to
it's
label
the NMR, it's always the
A,
H's
B,
for NMR.
C, and D.
I thought we did it.
Okay. Integration. I'm just doing eyeballing.
Oh,
I'm just
okay.
eyeballing
And
the
this.
integration here. Because I'm too lazy to go find my ruler again. But it
I
looks
don't
to me like
understand.
these
So
are
could
equal.
ask Carter.
Do you agree?
Yeah.
This
You mean the
distance,
C?
again, just eyeballing
Ask
this
Carter.
distance, and these seem to be about equal to me. Am I right? Reasonable? Not reasonable.
Yeah.
So then what about this distance? It's about 1.5.
Yep.
This is 1, this is almost 1.5. So what makes sense if you have 1.5?
4.5 times 2 is 9.
4.5.
She lets me drop
Oh,
it.
okay, okay,
She lets me
no,
drop
I
the
got it
class.
harder, you're right.
I think
4.5 times 2 is 9. So what, how many hydrogens
Go to the
is A
register and
for?
if they tell you if you bring me a coupon
Good.
or, you know,
B.
something in written,
C.
then we can do it
And
and
how
go
many
back to her and say,
hydrogens
hey,
is
they
B?
told me.
Everybody okay?
Yep.
Cool.
I'm
If it's
enrollment.
3 hydrogens, homotopic hydrogens, what group is that
So we had the
suggesting?
exam this week.
Methyl
I
group.
had the
If
exam
there are
last week
2
because she changes the
homotopic
date.
hydrogens,
If I
what
had it
group
last
is
week, I
that
would have felt last
suggesting?
week. I could do
Now,
that much.
You
These
can
are
use that.
benzene
I
hydrogens
can say
A
that
and
because that's her
B
fault.
integrating for 2 and 2 and a doublet
can
and
do
a
that.
doublet. What is
I
that
think
telling
it's
us?
fair. Sounds very fair.
Really?
Without even thinking, we can
Just
say, well,
treat it
that's 1,4
calmly
disubstituted
and-
1,4
benzene.
disubstituted benzene.
Everybody okay?
Yep.
Guys, can you see this
but
C and D? Please notice the multiplicity of C. C is a quartet. Do you see that?
Yep.
Because that's
D is a
not fair then.
triplet. Do you see that?
She doesn't like me.
Again, we've said this before. You have a quartet and a triplet integrating for 2 and 3. What must be this group? Louder? Absolutely. Right?
Yep.
This is C is a CH2, a quartet. D is a CH3, a triplet, which means this is connected to that, which means this is connected to that. What is the combination of the two? An ethyl group. Are you guys together? Okay? So what do we have so far? We know, good, what kind though? 1,4-disubstituted benzene, we know we have that. We have an ethyl so far, okay?
And oxygen.
We need oxygen and chlorine.
is that it? So
Yes.
6, 7, 8, 4 plus 5, 9. Okay, so the only thing we now need, oh, what about IHDs? How many IHDs have we used up in these two pieces? 4. So we are done with that also. So what's left? You said an O and a what? And a CL. Isn't that right? Let's put them together. How many different combinations can you come up with by putting these together? Where's the CL going to go? There's something seriously wrong with this formula. Because base 3.5, 3. It's 3. Okay. Okay. The only. Okay. Do you agree that I can put these pieces together in two different ways? One is put CL, put O, SO.
Yeah.
Yeah.
But that's not matching the spectrum, which makes more sense to me, but it's not matching the spectrum. So the other possibility is if, exactly, that's why I'm baffled. I think my formula is wrong. When I figured out, I think I did some mistake in there. But those are the two possible ways, though. Let's just go through the process, at least analysis. But do you guys agree that those are the two possible ways we can compile these pieces?
Following
Is
the
there
outcome.
any other possibility that I'm not seeing?
We don't do
Okay.
the first one.
Now, so the reason why I'm doubting my chemical formula, to be honest, is because of this chemical shift. It's 3. Where would I expect that signal to show?
Free are alkyne.
It's not enough. Where should I expect those hydrogens to show? It's a CH2 attached to an oxygen. About 3.5 but higher, because methyl versus methylene versus methine, so maybe 3.7 or so, and that's 3. So that's why I'm pausing and I'm like, wait a second, something doesn't make sense here.
Between 2.0 and 3.
Where do we expect those to show?
CH2.
2.5-ish, right? Even though that's 3, but I can understand because this is might have some effect on those signals. So I'll be very honest, I'm a little bit doubtful here. If I had to pick one of those two structures that would align better with the spectrum shown, I would pick this structure. Although that structure just makes me queasy just by looking at that. But based on the spectrum, it can't be this.
It can the structure on the right can still perform resonance.
Oh yeah, absolutely. I'm not doubting the resonance part. It's just that we don't see too many O halogen single bonds in O cancer. That's why I'm pausing. But does the process make sense?
Yep.
Any questions about the process? How many of you enjoy solving puzzles?
This one didn't definitely get a clear answer.
This one didn't have a very clear answer. I totally agree. Yes,
Oh no, so I was having my hand raised when I was reading.
oh, I see. How many of you enjoy solving puzzles? Well, if you enjoy solving puzzles, you will have a blast. If you don't enjoy solving problems, it is going to make your brain hurt first, and then
It's already
it will
making
become fun.
I hope she lets me try.
Is this part of your handout or no?
Yeah, it's not. Oh, wait. Yeah, that's alright.
Let's give this a try. So sorry about this. The other answer was a little bit ambiguous based on what we have. IHD, please.
Let's just. 4. Boom, I got it.
IHD. The more you will solve, the more comfortable you will get. That's the whole point.
Yeah. Yes. I got 5.
Because here's
5?
so many people.
Can someone confirm IHD 5?
Yeah.
So should we?
If she doesn't, I'll just keep going. But I'm tired.
22. H22.
What's your GPA?
My GPA is 3.5.
So should we think about
Oh, so you
benzene,
drop a little. You want to keep it there.
right? Agree?
The thing is, she's annoying.
How many signals?
It's her fault, honestly. Because I would have dropped out if I did.
I heard eight. Eight?
Five
This week,
Five?
I
Am I looking at
can't. She
my
needs
How
to
do
give
you
me
see
a
eight?
code.
Eight.
Oh, wait. Oh, I'm counting each line. Why am I
Oh, no,
counting
no,
each
no, no.
line?
Her timing is so fucking
No, yeah, you're right. One, two.
Everybody okay?
I will
Yeah.
post.
Yeah.
Integration. Okay, this one I have an answer, which I can't find. Okay, I don't know if you guys have a ruler or not, but again, I'm eyeballing and I can see that this is 1.5, 1.5. Of course, ruler is going to be a better way of doing it, so you can actually measure and confirm that that's what kind of it looks like if I just eyeball across. Okay, so what makes reasonable sense?
2, 3, 2, 2, 3.
So this is for 2 hydrogens, 3 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. Make sense? What is that a total of 12 hydrogens?
Yes.
5. Okay, cool. Okay guys, can you tell me what can you conclude from these 2 signals alone?
It's in the benzene.
Yes, what else can you conclude? Yep, they are benzene, but what else? Notice the total number of hydrogens in the
Oh.
benzene are 5.
Yeah.
So what does that tell us about the benzene ring?
Wouldn't it be like this?
It's a mono-substituted
Mon-
benzene.
oh,
Yeah.
It has only one other group on it.
Wait, so if it's just 2 and 3, it would only have one. What's it called? My bad, never mind.
One branch.
Mono,
brand?
mono
But yeah,
substituted.
how many hydrogens on, what is benzene?
Oh yeah, because never mind. Because there is a method. That's the method.
This is benzene.
Yeah.
How many bonding places does it have? 6.
Yes.
If 5 of them are taken by hydrogens,
There's a method.
there's only one
Oh.
more,
Okay. Yeah, my bad.
right?
Yes.
Make sense?
Makes sense.
So we should perceive B as a double signal, really?
Doublet?
No,
No,
the
C,
B is
what?
a double signal.
Say that one more. Oh, yes, absolutely, yes,
Alright.
you're right. B is basically 2 types of hydrogens put together, yes, absolutely. Now guys, I want you to notice C, D and E. Please notice C, D and E. What's the multiplicity for C?
Triplet?
What's the multiplicity of E?
Oh,
E.
E's triplet?
E for elephant.
Sure.
Yeah.
What about D?
Oh, is it a?
Notice not quartet. Please notice. Do you see that tiny thing? Do you see those?
Yeah, sextet.
Exactly. Of course, it would be a great idea if we were doing this experiment in the lab, it would be great to select that and expand it to ensure that it's actually a sextet. Yes?
Sorry.
Yeah.
How did we get the 2 H's and 3 H's?
Because the integration is 1 and 1.5. And 1 and 1 and 1.5. So if I multiply all of them by 2, this becomes 2, this becomes 3. Is that what you're asking though, Carrie? Yeah. And that also, it makes, that also is reasonable because the total number of hydrogens, 3 plus 2 plus 2 plus 3 plus 2 equals 12. So it's like, okay, that's a reasonable conclusion. We good? Coming back to C, D, and E, what can we conclude, guys? C is a triplet, D is a sextet for 2 hydrogens, and E is a triplet for 3 hydrogens. So we have a CH2 and a CH2 and a CH3. How do we put these together to align for the observed multiplicity? Whenever you see that pattern, triplet, sextet, triplet, it has to be a propyl group.
Purple.
Because that's the only way, oops, sorry, that's too low for the MC. That's the only way we will get that to be a triplet, this to be, and
It's a purple.
that's the only way possible. We good, everybody? So what do we have at this point? We have a monosubstituted benzene. How many carbons and how many hydrogens in the monosubstituted benzene? How many carbons in this piece?
6,
How many hydrogens in this piece?
5.
What about the propyl? The other is we have a propyl. So how many carbons and hydrogens have we accounted for in that piece?
3 carbons.
3 carbons and
3 carbons, 7.
what's the total that we've accounted for? And? Isn't that right? Isn't that right?
No, we need 10 carbons.
No, okay. We've accounted for this much,
Oh, yes.
right? How many IHDs have we accounted for? In these two pieces alone, just considering these two pieces, how many IHDs is that?
5.
Not really. I'm not asking you how much you calculated. I'm asking you that if we have these two pieces and this piece, we have accounted for 9 carbons, agreed? Total of 12 hydrogens. And how many IHDs are accounted for in these two pieces?
4.
4 only. What's left? No, so what's left? Let's account, we have of course an oxygen, what else?
And a carbon.
And what else?
Double one.
And an IHD, one IHD is left also. How do you, and you said double bond, how do you combine these through to a double bond?
Incredible.
That's your 5th IHD. Everybody okay? Now have we account, so I'm just going to put that piece in here also. A carbon oxygen double bond. Have we accounted for all the carbons in the formula?
Yep,
Have we
10.
accounted for all hydrogens and all IHDs?
Yes.
Let's put these pieces together and see how they come together. What is it that this molecule? Is that agreed? Signal assignments. Where is A? Where are A's?
That one.
Right? Where are B's? Right? C, D. Everybody okay? Make sense? Yes.
I was just wanting to get this down.
Right? And I think the keys are also on canvas, so we are going through the process. How does this look? Of course, there are more examples, and of course, you need to work on them yourselves to get good at it. But I want to give us another handout today, and maybe do a couple of examples from that handout together, and then we will be okay. But do you see the process,
No, I don't see anything.
do you see the patterns? Do you see the process of how to go about solving these puzzles?
Where do you go?
Ali?
I'm so out of it. Make sure you have one.
I think we're all. I'm so tired. Please let me go. I'm praying. So I'm nervous. I think I'm changing my major.
No, you're good.
It's hard. It's getting to the point where I just want to kill myself.
Don't give up.
What?
You're gonna ace it next time.
Okay, you
No
take
worries.
one. Is that the right one? Yeah. Wait. Could you pass?
You're gonna be happy.
Pass it to.
Give it one
Just
more
pass.
time.
Okay, guys, can we look at this second question on that handout? The keys are on canvas, so hopefully you will be working through the rest and figuring out the answers on your own so you get practice. But do you see this one? It for some reason says 6 because I used to have a different handout that I used to.
Wait, what? This one says 5.
I want to just talk about one thing here which we haven't seen
Yeah, you just
before.
turn the
Oh,
page.
turn it. Okay. I thought it was the first page.
Are you guys ready? Sorry, but it shouldn't be hard to find a page in a handout. Okay.
Just,
Do you see this information right here? Mass spectrum, the peak due to molecular ion, base peak, blah, 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 blah. We don't do mass spec in our class. So just FYI, whenever they talk about something called a molecular ion peak, not the base peak, the molecular ion peak, M by Z, that is basically equal to the molar mass of the compound. So this is telling me that whatever structure I'm going to come up with, the molar mass is going to be 150 grams per mole. That's what the molecular ion peak in mass spec does. Base peak is different. What happens in mass spec is the molecule breaks apart into pieces depending on its structure, and base peak is basically the piece that has the highest concentration. We don't need to go into that part. But when you see molecular ion peak, that's its molar mass. So it also is a clue that, okay, whatever you come up with has to have the molar mass of that. Because notice in this question, they didn't give us a chemical formula. So you have no IHD, you have no clue there. So we have to make sure that the whatever structure you come up with matches the molar mass of 150 grams per mole. But they do give us IR. IR about 1676 centimeter inverse. That can be a couple of different things. I'm going to hold my judgment on that for now because it could either be a conjugated C double bond O or a carbon-carbon double bond. So I'm going to hold off on that a little bit. But let's look at the NMR. Do you see again, please notice benzene, right?
Yep.
Please notice doublet, doublet. Please notice integration, equal, equal. What does that tell me?
Disubstituted benzene.
But what kind of dye-substituted benzene?
1,4.
Exactly. That's a very clear clue. It is a 1,4, which means this is really 2 hydrogens. Which means this is really 2 hydrogens, right?
Okay.
So then what is the integration for this signal right here? If that is 2 hydrogens, what do you think this is?
3.
And this, the next one?
Same thing.
3, right? So that means we have 2 different methyl groups. Am I right?
Mm-hmm.
Cool. So let's do this very quick math, guys. Very quick. Can someone tell me what is the mass of this piece? That is C6H4. What is the mass of C6H4? Quick math. Carbon is 12. Come on, guys, we know this. Calculators.
76.1.
Phones have calculators. Let's pick it up.
76.10 grams per mole.
Okay, 76. I'll just take 76 as a round figure. 12 times 6 plus 4. Agreed?
Yeah.
And what about CH3 and CH3? There are 2 CH3. So what will be the total mass of 2 CH3? 30. What is 76 plus 30?
106.
Right? Everybody okay? What's left? Molar mass was 150.
So we need 44 more grams per mole.
Everybody okay?
Yeah.
But it can't be a carbon, it can't be hydrogen, because there are no more carbon-hydrogen signals here. Also this IR, that's, okay. So it can't be, sorry, I misspoke. It cannot be something with hydrogen on it, because there are no more hydrogens for us to account for,
It'll
okay?
have to be something with oxygen.
It can be, it can also be carbon, just not with a hydrogen. Cannot have hydrogen on it. Okay, so
Yeah, C double bonds.
here's where mental math is going, especially with the IR given. What if this is actually a C double bond O? What's the mass of CO? What is C?
The total's 28,
So what is 44 minus 28?
16.
What is 16?
Oxygen.
So what does that tell me?
There's an oxygen.
There are 2 oxygens and carbon. So here are the pieces we have, guys. We have 1,4-disubstituted benzene, right?
Yep.
We have 2 different
Methyl groups.
methyl groups. We have a carbon with no hydrogens, and 2 oxygens with no hydrogens either. So we need to now take these pieces and put them together. Does anybody have suggestions? I do. Do you have a suggestion? Oh, okay, here's another clue. I have another clue for you. Look at this chemical shift, 2.5-ish. It's a methyl with 2.5-ish. Methyl with 3.8-ish. What is that saying?
Methyl.
Bunch of oxygen, but it's less rich.
OCH3.
So how do we put these pieces together to account for all of those clues shown in the spectrum?
3.7.
We can't add any more hydrogens because otherwise they would have shown up.
Yeah. OCH2.
There's no CH2.
Okay.
You can't add any hydrogens or anything.
OCH.
Oh, yeah.
Oh, yeah.
You get it? Yay!
That's it.
Oh.
So when you see this structure, if I were to again call them A, B, C, and D, then this is signal D, this is signal C, and then that's ortho or next to, so resonance, these are going to be more D-shielded, signal A, these are signal. Yes,
Wait, so what explains the other shift then?
what should,
The shift of D? Because D's like shifted further up.
instead of being 2, it's, I think because this whole thing is pulling resonance, is pulling electron density towards, it causes that carbon to be electron deficient, which causes this to also be D-shielded. So instead of being 2, it's actually 2.5. Yep.
Right, makes sense.
And it looks like it's 2. And the graph also says so.
Spectrum, please, Carter.
Oh, the spectrum
It's
says
like-
it. Spectrum says it too.
So the important part I wanted to mention here, if you ever came across something that said that, please remember, this is the molar mass of the compound. Okay, there are a bunch of others, but I want to skip to this. We have literally less than 5 minutes. So we learned IR, we learned NMR, proton NMR, so we should be able to put them together. That's the whole point. These tools don't work in isolation. You gather clues from all possible sources to do what you need to do. So here's, once again, formula, IHD. As soon as you see formula for whatever question, if the question gives you a formula, instinctively calculate the IHD because you don't know, it might help. So what's the IHD of this compound? C10H14O.
IHD is 4.
Okay. Now let's look at the IR. Let's gather the clues we can from IR. What does this tell you?
OH bond.
We all agree? That's an OH bond. I'm labeling my IR because when you see IR, I will ask you label the signals, which means you're telling me which signal corresponds to which bond. Okay, do you see these peeping through?
Yeah.
What is that? The what? SP21?
SP2CH and SP3CH.
And these are the SP3CH.
Mm-hmm.
Now there are a bunch of others in the fingerprint area, but I'm not 100% sure that most of those really are needed. Because there is no C double bond O, there's no C triple bond C or C triple bond N, there's no C double bond O, at least not a strong one. I don't know, I might have to come back to that. Of course, these could be C double bond Cs. Benzene has C double bond C, so that makes sense. But for now, I mean, that's useful information. We good? Let's go to proton NMR spectrum. How many signals do you see? I see four.
4 signals.
A, B, C, D. Of course, the combination of A and B is for integrating for 4 hydrogens. A and B together are integrating for 4 hydrogens, right?
Yep.
What does that suggest? Notice the area.
And
Which kind?
one more.
Because that's a doublet, that's a doublet. 2 doublets, equal size almost. So that is, again, a 1,4 disubstituted benzene. Okay, I'm going to come back, come to this in a second. What about this big one at around 1.2 or so, integrating for 9 hydrogens? What does that suggest, guys? Let's use some critical thinking here. You have a signal in one signal, integrating for 9 hydrogens. Louder? Well, then why should they be all equivalent? If it's a chain, they will not be equivalent. Not isopropyl, because isopropyl has 2 different kinds of hydrogens. That's nine is the clue.
Is it 3 separate CH3s?
But separate CH3s, but they are equivalent to each other because it's the same signal. If they are same signal, yes, there are 3 CH3s, but they are in such a way that they are identical. What does that indicate? That's the only way possible for 3 different metals to be identical to each other. Everybody okay?
Yeah.
So what have we used? Oh, what do you think this might be? For 1 hydrogen, it's exactly. Because IR told us we have an OH. IR told us very clearly we have an OH, so that's probably the OH hydrogen. Okay, so we needed 10 carbons. Have we accounted for 10 carbons? 6 plus 4, 10. How about hydrogens? 14, we need total of 14 hydrogens. 9 plus 1 plus 4, yep. All we have to do is put these pieces together. How do we take these 3 pieces and put them together, make a molecule? Suggestion? We'll stop right after that.
Just slap an OH on one side and turn on the other side. Turn, whatever, close enough. Turn is his nickname.
You're done. Absolutely. Sounds okay? So here's the plan for Monday. Quiz on Monday will cover IR and NMR, but not these kind of. Not here's the spectrum, tell me. I think we need more practice for that.
Yeah.
However, I need you to do the practice. So quiz on Monday will cover IR and NMR, but I won't give you the NMR kind of things that we did today. I won't give you those. But whatever we did till Monday, we should.
Oh, okay.
What I also need you to do, I need you to be practicing these worksheets, because guys, I can give you tons and tons and tons of worksheets, but if you're not actually working through them, practicing through them, it's really not useful.
Yeah.
So that on Monday you can come and tell me, hey, can we do this again? Can you please, can we work on this together? Otherwise, we go to carbon NMR. Then we finish carbon NMR on Monday, which makes us very comfortable the week after Thanksgiving.
Okay.
Sounds okay?
Sure.
Please be working through these. It's based. I have your exams too. Please don't run away. Please be working through them.
Thank you.
So that you start getting an idea. And yes, on Monday, if you tell me you want to work on some of these, I will definitely dash.
Oh,
Don't dash away.
I gotta go somewhere.
Pause. No, I'm just kidding.
That's like the only thing I was confident in. I'm glad I got
Yeah.
that right.
Oh, I'm not sure.
Yeah, you don't change carbon at all.
Yeah.
Carbon's not meant to change.
I think that's.
Remember, the carbon should always like filter out, you just.
Oh,
Well, that's 1 point.
Yeah, so, yeah.
I was like, no way, there's no way.
Oh, there's nothing.
I got all the time.
No, okay,